We're going to figure out how to simplify some imperfect squares. So, oh man, I should have taken out the numbers here in this first one, but that's okay. Can I get a volunteer real quick to read out this first little sentence here, starting with all of the roots? Go for it, Kenny.
All of the roots we found above the rational numbers, meaning they can be written as a fraction. What if we take the square root of a number that is a perfect square?
Thank you very much, sir. So, yesterday, well, we're going to talk about, on Thursday, we're going to talk more about what rational numbers are, what irrational numbers are, real numbers, all that stuff. We're going to talk about that on Thursday, but for today, we're just going to worry about what if a number is not a perfect square? What if we have a number like 12, right? 12 is not a perfect square. 9 is a perfect square. What's the next perfect square? 16 is a perfect square. 12 falls somewhere in the middle, right? So when we don't have all identical factors for us to take out, all we do is take out what we can and leave whatever doesn't have a matching pair. So if we have 12, right? If we have 12, we're going to split 12 up into what numbers multiply to get 12, right? So I'm going to do a little factor tree over here on the left. And I'm going to ask you what two numbers multiply to give us 12? 6 and 2, perfect. 3 and 4 also would have worked because now we need to split up 6. What two numbers multiply to give us 6? 2 and 3, right? So in the beginning of the year, we talked about prime factorization, right? This right here is the prime factorization of 12. And I'm going to write that right above it. Prime factorization. Okay, and what that means is that we've broken 12 up into only prime factors. 2 is a prime number, 3 is a prime number, and 2, again, is a prime number. Once we split all those numbers up, we can write them just like this. 3 times 2 times 2. The same exact thing as 12, right? 3 times 2 times 2, that equals 12. We just found that out by creating this factor tree. And what do we have an identical pair of inside that square root? What number shows up more than once? 2, right? So we're going to take those 2's and we're going to bring them out in front. Exactly what we did yesterday, except now our square root sign can't disappear because there's still something left over. That little 3 in there. So the 2's came out in front. We got plus or minus 2 times the square root of 3. This is what's left over on the inside. Again, in the same way that we reduce fractions or simplify fractions, we can only cross out factors that have an identical twin, right? That have a pair in there. The 2's are paired together. But this 3 does not have an identical twin, so it's got to stay inside. Okay? Of course, we do still need to put a plus or minus sign in front because we don't know if we pulled out a positive 2 or if we pulled out a negative 2. They're both possible. So we have to include both options. So the key idea here is pulling out whatever identical factors we find. Therefore, our answer here is just plus or minus 2 times the square root of 3, which is a really ugly looking number, right? This is just as much a number as 4 or 5 or 10. It's just written in a way that we're not really used to seeing typical numbers written out. So, the square root of 12, right? I said it's in between the perfect squares of 9 and 16. So that means that this number should be somewhere in between the numbers 3 and 4. Let's see what happens when we put it into our calculator. 2 times the square root of 3. I predicted it should be somewhere in between 3 and 4, and that's exactly where it is. 3.46, blah, 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 doesn't matter, right? So this is going to come in handy when we look at the next note sheet, but let's just finish out this one first. And let's try and simplify some of these together. Let's start with 18. I'm going to go ahead off to the side here and do a factor tree, just because factor trees really help me see what the factorization is for each of these numbers. So, what two numbers multiply to give us 18? Who can help me out here? Jordan, go for it.
6 and 3.
6 times 3. Perfect. 6 times 3. Now, can we split up 3 anymore? No, but we can split up 6, right? What two numbers multiply to give me 6? 2 and 3. There's my prime factorization. 2 is prime, 3 is prime, and 3 is prime. Remember, a prime number is just a number that can't be divided anymore. So 18 is equivalent to 3 times 2. That's how we break that up inside the square root sign. Now, what's the identical pair here that we're going to pull out? The 3's, right? We circle up those 3's, bring them out in front. But what's left over on the inside of our square root? 2 is left over. So for our answer, we're going to have plus or minus out in front. 3, right? We brought that 3 out. But what's left on the inside of our square root is that 2. So we brought out that pair of 3's. We left behind the lonesome 2. And our answer is plus or minus 3 root 2 is how we would say that. You could say 3 times the square root of 2, but that's kind of a mouthful. I would just say 3 square root 2. So read it left to right. Plus or minus 3 square root 2. Give me a thumbs up if you see how we got that answer based on that factorization. Anybody? Couple people? Good. Okay. Let's kick it up a notch. Let's go to 24 now. Let's go ahead and factor out 24. What two numbers, now there's multiple options here, but what two numbers multiply to give us 24? 6 and 4. We could do 6 and 4. We could do 12 and 2. We could do 8 and 3. Does not matter. I'm going to go with 8 and 3. Remember, when we're doing a factor tree, it doesn't matter whether we do 6 and 2, whether we do 6 and 4, 8 and 3, or 12 and 2. Because we're breaking each of those numbers down further anyway, right? What two numbers multiply to give me 8? 2 and 4, right? And what two numbers multiply to give me 4? 2 and 2. So here are all 4 of our prime factors. 2, 2, 2, and 3. 2, 2, 2, and 3. Yes? Sure. Do we have an identical pair we can pull out?
Yeah.
Yes, we have a pair of 2's. Now, anyone have an idea of what's going to happen here? Because we don't just have a pair of 2's, right? We have a triplets of 2's. Can we pull all 3 of those out, you think? Good. We would think, yes, we can pull them out. But we have to, how should I say this? We can only pull out pairs, okay? We can't have a plus 1 here with this additional 2, right? You guys all heard of like the old like Noah's Ark story, right? Where the old guy, there's a flood coming and he's got to bring 2 of each animal on his boat, right? Does that sound familiar to anyone?
Yes.
Okay. So think of it like that. Everyone's got to go in a pair. Can't have an extra hanger on. This 2 here's got to stay inside the square root. Okay? Let me show you what's going to happen. We're going to have plus or minus in front. We brought those 2's out, so we're going to have a 2 in front. But what's left over in the square root? Well, there's a 2 and there's a 3. Exactly. Now, our brains are tricky because they'll tell us, oh, if there's a 2 and a 3, we add those together, there's going to be a 5 on the inside. But look at this sign in between those 2 numbers. It's a multiplication sign, right? So we have to multiply 2 and 3 together, and we get 6 on the inside of our square root. We can only pull out identical pairs. Whatever's left over on the inside, if it's just one number, like in our first example, that one number stays on the inside. But if there's multiple factors that don't get pulled out, we've got to multiply them together to get whatever number we're going to keep on the inside. Does that make a little bit of sense to anyone? Okay, cool. Go ahead and try the square root of 27 on your own. Write a little factor tree off to the side. Break up 27 as much as you can. And see what you can get as a result. I want to take a walk around here and see what we're able to do on our own after that. Let's give 27 a try. Perfect. Good. Man, it was you. Okay. All right. What 2 numbers multiply to give us 27? 3 and 9. Perfect. Now, what 2 numbers multiply to give us 9? 3 and 3. So our prime factors are 3, 3, and 3. We'll put those in underneath our square root right there. And what's the identical pair that we can pull out here? Pair of 3's. Can't bring out triplets, only twins. So our answer is going to be plus or minus 3. And then what's going to be on the inside of the square root? 3, that's right. Exactly right. Plus or minus 3, square root 3. Of course, don't forget about the plus or minus sign. I had to add that in on the bottom just so we don't forget. Now let's do 40 together. What 2 numbers multiply to give us 40? 4 times 10. So we can split 10 up into 5 times 2. We can split 4 up into 2 times 2. So what we've got here is 2 times 2 times 2 times 5. That's going to give us 40. What's the identical pair we can pull out here?
2.
Pair of 2's, bring those out. Now we're left with a 2 and a 5. So what are we going to have underneath our square root? A 7?
No, 10.
No, we're going to have a 10. That's exactly right. Plus or minus 2, square root 10. We have to multiply those 2 numbers together underneath the square root. And that right there is what we get. Quick show of thumbs, how are we feeling about doing this on our own? Or maybe not on our own, but how are we feeling about just wrapping our heads around this idea real quick? Okay. I see mostly thumbs up, a few sideways, and that's okay. Once we get talking on the worksheet, we'll take a look at some more examples, but let's switch gears here and go to note sheet number 5. I think, honestly, I did these a little bit out of order. I think it should have been 4 and 5 flipped around, but it doesn't matter. Because now what we're going to do is estimate square roots. So what we just did was technically simplifying. Okay, note sheet number 4, what we were doing was simplifying square roots. Note sheet number 5, now we're going to estimate square roots. Can I get a volunteer to read this first little passage up here for me? Kenny, I heard your voice already. I appreciate it. Let's go Noah for this one. Go ahead, Noah.
You can also find an approximate square root for these non-perfect squares. You can estimate those roots by identifying which two perfect squares a given number falls between.
Bingo. Thank you, sir. This is the important part. Which two perfect squares your given number falls between? Okay? If this was a calculator-infused classroom, we could just plug all these into the calculator and get a decimal estimate of up to 2 places, right? But we don't have calculators. Some of you might, that's fine, but since we don't have, yeah, Brandon, yeah, go ahead. Since we don't have calculators in here, we're going to estimate instead. The way that we're going to do that is with note sheet number 2. Once again, we're coming back to this. Note sheet number 2. This table here is going to help us out a lot this unit. Here's what we're going to do. Let's say we have the square root of 18. Okay, we can identify right away that 18 is not a perfect square. Go ahead. So we can tell 18 is not a perfect square. What we're going to do is we need to find the 2 perfect squares on either side of 18. What I mean by that is on the number line, right? So if we look back at our chart, right, we're looking at just the, actually let me get my actual chart from yesterday. So we're looking at all the orange numbers here, perfect squares, looking for whatever numbers are going to be on the left and the right of 18. So we've got 1, 4, 9, 16, 25. It looks like 18 is going to be in between 16 and 25. You guys see how I figured that out? 16, 18, 25. 18 is going to be right in between 16 and 25. So these are the 2 perfect squares that 18 falls in between. Therefore, we can estimate that this square root of 18 is between 4 and 5. Why 4 and 5? Well, those are the roots of 16 and 25. Just like I mentioned, we can verify on the calculator that the square root of 18 is in fact in between 4 and 5. Just like that. Right? But we don't want to mess with all those decimals. We just need an approximate or an estimate. Somewhere between 4 and 5. Now what about the square root of 68? Well, that number, if we take a look back at our chart, we're looking for where 68 would fall between 36, 49, 64. Ooh, 64 is close. 81's the next one. So 68 is going to be in between 64 and 81. So our square root is going to be in between 8 and 9. (64) and 81. So our square root is going to be between 8 and 9. We don't have to do a factor tree. We don't have to bring anything outside of the square root. We're just making an estimate, or an educated guess, as it's often called, right? It's not a pure guess. because we're using our chart to see what perfect squares are around that number. And then we're using those roots to identify what the estimated square root is going to be. For example, if we look down here at number 1, we got the square root of 6. All you need to do is look at your orange numbers here. It's going to be in between 4 and 9. So my root's got to be in between 2 and 3. All you have to write down is between 2 and 3. Number 2, we got the square root of 90. We again take a look back at our chart. 90 is probably closest to 100, but it's going to be a little bit less. So 90 is going to be in between 81 and 100. Right? In between the perfect squares of 81 and 100. So our root is going to be in between 9 and 10. All we have to write is between 9 and 10.
It will be like 9.4666 or something like that.
Well, let's see. Square root of 90 is, 9.486. Yeah, you were close. Somewhere in between, right? Obviously, the closer we get to one or the other perfect square, the closer your decimal is going to be to that number. But this one's pretty much right in the middle, right? Give number 3 a try on your own real quick. Square root of 21. Find which two perfect squares that falls between. Take those roots, and that's going to be your estimate for this one, for 21. Take like 60 seconds. Flip back to note sheet number 2 if you need to. We all have it from yesterday. And estimate where the square root of 21 is going to fall between. Yes, exactly. That's exactly right. That's all you have to write for your answer is that. Yes. Yeah. All right, give me a thumbs up real quick if you got the answer here for number 3. Anybody already figured it out?
Yeah, I did.
Perfect. Leslie, help me out. What is the estimated square root of 21?
Between 4 and 5.
Between 4 and 5. Perfect. Absolutely right. Give me a thumbs up if that's also what you got. Between 4 and 5. Anybody good? Oh, perfect. Awesome. How do we know it's between 4 and 5? Well, all we do is take a look at our chart. Our number here is 21. That's going to be in between 16 and 25. So we just look over. It's going to be in between 4 and 5. Just like that. Okay? I don't know why 5 and 6 are the same. Just ignore number 6. Number 4, square root of 300. Anybody already figure out what that one is? Who's that in the front? Victor, go for it, Victor.
Between 17 and 18.
Perfect. Between 17 and 18. That's exactly right. And who's got number 5? Azalea, go for it.
Between 6 and 7.
6 and 7, exactly right. Between 6 and 7. We got 36 to the left on the number line. We got 49 to the right on the number line. It's going to be right there in between 6 and 7. So there's those 5 examples for you guys. I'll give you guys a little bit of time to soak that in, take it in.
We're in a different world a little bit.
Yeah, I was thinking myself in that seat.
All right. Any questions I can answer about this work? So, we learned two different methods here. We learned how to simplify these imperfect squares, and we learned how to estimate these perfect squares. Or imperfect squares, I'm sorry. So two separate things. Simplifying, we got to do the factor tree. Estimating, we just make a rough guess based on our chart. Okay? So when we get worksheet 54 today, on the front, you're going to have to estimate each square root, figure out where they fall between, obviously using your chart from note sheet 2. And then on the back, you're actually going to have to simplify those square roots as much as possible, right? That's going to be note sheet number 4. But for the front, you're going to use note sheet number 5. So it's a little backwards from the way that we talked about it. If you're more comfortable starting on the back and moving towards the front, that works. But I think the front's probably a little bit easier. You don't really have to do any math. You just have to use your deductive reasoning skills and your vision and eyesight, right? Okay.